Okay, so problem number 3 asks, place the digits 1 through 9 once each in the squares in figure 3 so that in each row and column, either the product of the numbers or the sum of the numbers equals the number labeling that row or column. So to start off, the best strategy for me is to write down all the possible digits that were given the problem. So that'll be 1, 2, 3, 4, 5, 6, 7, 8, and 9. And the problem asks that the digits will only be used once, so I won't have to worry about writing any other numbers down. And after I do that, I decide if these numbers right here are multiplication or addition statements. And by doing that, I think, well, 60 and 27 cannot be addition statements because even if you take the highest numbers from the sequence, which is 9, 8, and 7, it would equal 24, not 27 or 60. So I would put an X by 27 and 60, so I'll remind myself that it's a multiplication statement. And then on the other hand, 19 and 23 cannot be multiplication statements because they're both prime numbers, and it's only achievable if we add some of the numbers from this sequence. So I'll add a plus as a guidance that it's an addition statement. And then for 12 and 20, it could be either one. So I'll do a plus and an X. Again, just for guidance. And then these symbols will help me with the next step, which is placing the digits into the grid. This will make it a lot easier. So I'll start with the rows first. Factors of 27 are 1, 3, and 9. So I'm just going to place them into the grid. We'll worry about the exact placement later when it comes to the columns, so I'll just cross this off. And then for 6C, I automatically think that the factors would be 2, 5, and 6. So write that down here. And then since 19 is an addition statement, when you add 4, 7, and 8, it'll equal 19. Okay, so now that we're done with the rows, we have to make sure that it matches up with the columns. So if I were to start out with 23, because that's the easiest one, I'll take the highest number from each row, so then it'll add up to 23. So maybe switch that to 8 and 7, and then change this from 6 to 5, and then switch to 3 and the 9. 9 plus 6 plus 8 is 23, and now we have to worry about 20 and then 12. So if I were to think of this as a multiplication statement, I see 20 as 4, 5, and 1. So we can just test this theory out to see if it's right. And switch the 3 and the 1. And then it does work with the 20, so now that we're good. And then I would check the 12. And if it was an addition statement, 7 plus 3 plus 2 is equal to 12. So those are my final answers, so I'll just write them down in the final grid. And yeah, that's how you solve problem number 3.